This is Annette Kirkland, and welcome to Beyond the Gates. This season, we're going to be highlighting ERDC's legacy of groundbreaking research and cutting-edge technologies. Join us as we explore how innovation continues to drive progress in military and civil works missions.
And I am here with Drew Miller, and he is with the R&D engineering technician. He is an R&D engineering technician in the Paint Technology Technical Center of Expertise with the Construction Engineer Research Center, otherwise known as CERL. And we're going to be talking about painting a brighter future, the ERDC CERL Paint Technology Center. Good morning, Drew. How are you?
Good morning, Annette. How are you? I'm doing well this morning.
Good. We've just got a lot to talk about this morning. You know, in developing these questions, I did not know that we had a paint technology center. So it was fun to dive deep into what you do.
You actually get that quite a bit, which is, maybe shame on us for our lack of marketing, I guess.
Well,
but we're trying to get better about that, across the USACE and, really the nation as a whole.
Right. And that's why we do this show. That way people can find out. We can play the ERDC story for everyone, and everyone will find out what goes on with ERDC. So tell me about yourself and your background.
So a little bit about me. So I grew up in a small farming community about 20 minutes from CERL, actually. So it was kind of my own backyard growing up. Growing up, just the average kid, played football and golf and kind of just ran around in my little farm town and worked in agriculture from a pretty young age. Used to tassel corn. If anybody knows what that's like, it's not a lot of fun. But started doing that at about the age of 13 in the summers, just something to stay busy and get out and make a little paycheck, So that kind of led me into my oddball background, I would say, where I ended up studying business, agricultural business and agronomy, which is like crop and soil science over at Illinois State University. So about a 45-minute drive from CERL.
Mm-hmm.
And we're actually standing up a new research agreement with Illinois State right now. So that's one exciting thing going on over here at CERL. But during college, I ended up kind of staying plugged into the agriculture industry. So I worked as a field inspector and worked in warehousing and logistical roles across the industry during that time. And then as I got towards the end of college, I decided to pursue a commission as an Army officer on the active duty side. Did a kind of an unconventional route to get in. Instead of doing ROTC or West Point like a lot of folks do as they go through college, I decided a little late in the game and went in after the fact. So I went through Officer Candidate School, OCS. So I started my time by going through basic combat training like an enlisted soldier and then down to Fort Benning. I forget the name of the base now, but that just changed. But down in Georgia, where I earned my commission as a second lieutenant. That was really a unique opportunity to start what I would say my real professional career.
Right.
Industry. So I got down there and had some excellent NCO non-commissioned officer mentors that were going through the course with me as well. And they, really guided me and helped me place high enough on the Order of Merit list down there. So I was able to select my path forward in the Military Police Corps, where I served my next couple of years. And then once I got out of active duty there, I ended up falling into the commercial transportation insurance world. So a lot of people don't really know what that is, but basically if it was commercialized on wheels, we insured it. So it was traditional, tractor trailers like you see rolling down the road to
right.
Crane companies and ambulance and black car shuttle services, everything commercial on wheels. So I was a loss control specialist for those guys and spent a few years with them and managed about a 5-state region of customers where it was a 10-truck mom and pop shop, little family-owned operation all the way up to about 6,000 unit fleets. So we'd go in and I'd go in a couple times a year to meet with these guys, and I'd review their federal and state DOT compliance and OSHA compliance, look at their physical site security, their accident history and trend analysis, their safety and training programs for drivers. And so I would actually help them. We'd basically go in and play defense. So I'd go in and help them get into compliance through little mock audits, make sure they're not getting fined, help their drivers be safer out there on the road. things like that. So that was a pretty great opportunity. You know, we spent a lot of time on the road, so that was really hard. We were gone about half the year, traveling and meeting with customers and everything. But that's when I kind of was realizing I wanted to settle down, start a family, you know.
Right.
So that's what led me to CERL actually in 2019, which was quite a time to try to get on at CERL. But yeah, so in 2019 is when I started trying to look for a change. I wanted to get off the road and settle down, and I realized as important as it was helping with, these safety programs and keeping customers from getting fined and, really helping protect their business, I realized there was a bit of a void from the Army that I didn't quite recognize for a few years there. So I ended up applying over at CERL and just applied with a couple different teams for engineering technician roles. One of those teams being the paint lab that I'm with now. So thankfully that interview went well, and was excited when the call came in to get to work and get off the road, get over here back to the Army on the civilian side. And took a little while with COVID though. The pandemic was spinning up and the lockdowns were starting and stuff.
Right.
So I ended up getting delayed into July of 20 until I was able to jump on full time with CERL. But it's funny, when I was sitting there waiting, I was like thinking to myself, am I really going to want to go watch paint dry?
Because that's literally what you do. I guess that's what we should have titled the show, is watching paint dry.
Yeah, they actually, before my time, they had some T-shirts that they were wearing around the lab that said, yes, we watch paint dry.
Well, so that brings us to our next question. So what is your role at ERDC?
So I'm an engineering technician, as I kind of alluded to there.
Right.
And so, like you said in the beginning, I technically work for the Paint Technology Technical Center of Expertise. That's a mouthful, so we like to just call it the Paint Lab or the PTCX.
Okay.
Just a little bit here.
Everything is acronym around here.
Oh, yes. We love our acronyms on both the active and the civilian side.
Right. Exactly.
So I work for Dr. Rebecca Wilson. She's the head of our research and development program in the Paint Technology Center. So as a technician, I get to kind of be a catch-all for whatever needs doing. So I do a lot of just our day-to-day lab execution for different projects. I've also kind of spearhead the lab safety for our team in our paint lab footprint. So trying to make sure we stay in compliance, working with our CERL and ERDC level safety directors, and making sure all of our new employees, whether they're technicians or junior researchers, are trained up on just general lab operations, on safety, on how to run equipment, things like that. Then I also dabble in our future planning and logistics for our paint lab team. So trying to look out to the future and say, okay, what are we going to need, not just next year, but 5 years down the road? What kind of space, what kind of equipment? And I know that all varies, being we're a reimbursable lab. We have to go at FY by FY for funding, but how do we position ourselves for success in the future?
Right, right.
So it's really something new each day. It really keeps me on my toes. Great.
So we're going to dive into this. What is the Paint Technology Center, and what is its mission?
So this one I wrote down because we have a formal mission statement.
Okay.
So I'm gonna read that out, and then we'll kind of go into what that really looks like and means, if that's all right.
Absolutely.
So the actual mission statement here that we like to display for folks is the Paint Technology Center, TCX, which is Technical Center of Expertise, maintains state-of-the-art technical expertise, facilities, and instrumentation regarding all types of paints and coatings for use on military and civil works infrastructure. The center provides expertise and real-world guidance regarding specifications and installation of paints and coatings, in addition to cutting-edge R&D. And we do this by advancing paints and coatings technology to ensure resiliency and sustainability of our infrastructure through innovative R&D and field integration. So that was a lot.
So to sum it up.
Exactly. So kind of translate some of that. So our lab is in a really unique situation here for the Paint Technology Center. So we're actually the only DoD funded wet lab for infrastructure coatings. So there's other labs out there that focus on weapons and vehicles across the DoD, but we're actually the only ones that tackle infrastructure coatings problems. So that lets us have a pretty wide net of things that come through the door and a pretty wide range of problems. We're not just dealing with the Army, being in the Army Corps of Engineers, but we're also work with the Navy, the Air Force, with NASA, these other sister DoD organizations to help focus on their infrastructure challenges as well.
Right.
So kind of to give a little context on how that works. So our team is set up in kind of two lanes in the Paint Technology Center. We have the R&D side, which, like I said, is led by Dr. Rebecca Wilson. So there we're working on new innovative materials that are in various stages of development. So it may be something where we're testing a product that private industry has developed, and they're saying, hey, it's the next best thing since sliced bread, and we're going to really dig in and see if that's true.
Mm-hmm.
And other things, which we call like the 6-1 level, which is really introductory research. So that's where you're maybe taking a theory or an idea on a new coating and investigating that from the ground up.
Okay.
And so we do that with the help of not just our internal teams, but we work with a wide range of organizations across private industry, like different paint manufacturers. We have a lot of relationships with academia. So like a big one for CERL and really for ERDC as well is like the University of Illinois, to name an example. And then, like I mentioned, the other DoD partners as well. And so that's one side of the house. And then on the other side, we have what is called our field support and quality assurance side of the house. So that's led by Brooke Diven. And what that side does is they receive different paint samples. So like think a bucket of paint,
Right.
like a 5 and a gallon can. So different manufacturers will send these in, different Army Corps districts will send these paint samples in, and these samples have to get tested before getting used on like Corps of Engineer jobs, for example. So say we're going to paint like redo a lock or a different sector gate. Those come in and we'll go down and test these paints on everything from their chemical makeup and all the way through to their performance and workability of the actual coating. And then that side, Brooke and her team also spend a lot of time in the field where they're going out onto job sites and working with different USACE personnel, different private contractors that are on jobs, and they'll actually help get these guys trained up on application procedures, understanding the federal guide specs for what's, kind of governing the jobs, things like that, or just making sure the jobs are being completed to standard as they go as well. And so all that being said is the reason it's set up that way on our team, having the R&D side and the field support quality assurance side, it gives us a unique way to kind of approach R&D and circling back to the field. So Brooke and her side can go out to the field and they can come back directly with different problems and challenges that are faced in the real world on a daily basis. Mm-hmm. That can feed directly into our R&D efforts, and then vice versa. Our R&D, as it moves along, can help field directly back into the field to help, solve those problems and bridge those gaps a little bit more, I would say, accurately and more efficiently.
Right. We are just having a great conversation. And what are some of the current research projects that you are working on or involved in at the Paint Technology Center?
Oh gosh, this is going to be a fun one.
Oh, I like fun.
So like I mentioned, because of our kind of odd mission set there, where we get to focus on really all things infrastructure across the civil and military side of the house, it gets us into a lot of different areas of research that thankfully I get to be involved in. So one of our big efforts right now, some folks out there may be familiar with the Corps of Engineers vinyl paint system. If you're driving up and down the Mississippi, or you see another hydraulic steel structure on one of our navigable waterways, you're going to often see them as this gray color. That's usually vinyl. That was developed by the Corps back in the 60s time frame. Performs very, very well. So what we're doing is we have a rather large setup for what's called accelerated weathering. And so what we do is we take steel samples We coat them with vinyl and with all kinds of different replacements across different offerings through different R&D organizations, different private sector companies like different paint manufacturers. And so we'll pit these against each other essentially in this testing, where we test these samples by putting them in through 3 days of salt fog exposure in a chamber. So it's simulating like an island or oceanic high salt content environment. And then it's going to get switched over and it goes into a freezer, simulates a freeze thaw climate type situation. And then it spends 3 days over in a UV and condensation chamber, where it's exposed to the high UV degradation that we face when our structures are outdoors at all times. And so it goes through this cycle for about a 12-week period if the coating continues to perform. Some of them fail earlier. And so we do all this so that we can analyze how coatings perform at a little bit quicker rate than just setting them out in Mother Nature.
Mm-hmm.
But with this being a new R&D kind of area, we have to have a check and balance system. So we also do what's called atmospheric weathering. So it's where we take the same samples from the same coating, the same batch, and we put them out all over the globe, different climate and geographic locations. And so those take years to develop. And so we'll take those back at the end, and that gives us something to cross-reference our in-lab data with. Gives us kind of the real-world sanity check, and then that helps us dig into predictive failure analysis and modeling and things like that. So that's a pretty big effort that we work on.
Sounds like it.
Yeah, it really is. It's that one spans quite a bit of time, as you can imagine.
Right. I was just going to say, I mean, that I can imagine that's a long period of testing.
It is. Like I said, the cycle in the lab is 12 weeks, but we'll often let panels out in the environment for a number of years.
Right.
So it's a little more involved.
Right. And it's all about the data.
It is. We have to have, like I said, the checks and balances. You have to have the real world data to cross-reference with the lab data.
Right.
So another area that we're in is biological corrosion. So a lot of people think paints, coatings, they think corrosion, they think rust, like on metal,
Right.
But it goes a lot wider than that. We deal with anything that degrades any other surface. So that's where we get into biological corrosion. So a big one out there right now across the country is with zebra mussels. So they're an invasive species that's not native to the U.S. And so there's extreme regulations out there in place for when you're, even if you're a civilian transferring your boat between different waterways, between states, trying to stop the spread of these small mussels. They carry quite a bit of disease, but they also are really harmful to the ecosystem, where they filter the water naturally as they live in the body of water. And so they'll actually clean it to the point where it's detrimental and they're removing all of the positive algae and different bacteria that are in the water that keep ecosystems alive. Mm-hmm. But they also attach to almost everything, it seems like. And so these little guys will build up on our locks and dams. They'll build up in hydropower systems to the point where we're actually seeing like 50% weight added. So like on a gate, for example, those are thousands and thousands of pounds. But we'll actually see mussels building at such a rate by attaching to the gates and to each other that they'll actually add 50% of the weight of the gate back to that gate. So thankfully, the Corps of Engineers really over-engineered back in the day to where our systems are very robust. And so they're still operational, but these guys are really starting to cause quite a problem. Both in strain to the materials themselves, to the motors and stuff that are trying to lift and operate these structures. So right now we're trying to find ways to get these mussels to not attach to our structures. Mm-hmm. When you're working with stationary infrastructure like we do with like a lock and dam system, you can't use traditional anti-fouling coatings that you may use on watercraft, where they leach out slow amounts of substance that these mussels don't like. But because it's over millions of gallons of water and it's in motion, it doesn't harm the ecosystem. When you're stationary, like our hydraulic steel structures, that can be detrimental to the local marine life that are there. So it's kind of a whole different challenge we have to take, a whole different approach to this challenge that we have to take. So right now we're testing different coatings types, pitting them kind of against each other to see if there's actually almost like a preference where maybe the muscles prefer one certain coating over another. So we can try to find an alternative coating, even if it's only in set spots on our gates where it's those high attachment zones. But find ways to get these guys to kind of move on,
Right.
to leave our alone. So one of the other interesting areas that we've been working in lately is with our blasting media. So for those who aren't familiar with it, when you're preparing a steel structure or a metal structure, you have to do oftentimes what's called abrasive media blasting. So one of our medias that we like to use in the Corps here is called aluminum oxide grit. And so it's like traditional sand blasting, if you've ever heard that before. Sand's not really widely used anymore. It's a little outdated.
Mm-hmm.
But what we're digging into now is how to move on to the next best thing technology-wise. So like I mentioned, we use aluminum oxide grit now, but one thing that we're looking into is different alternative natural medias. So things like different garnet blends and things like that nature, to where we're trying to see, can we get the different profiles that we need for our coatings to bond to the materials properly, but then also, are there any benefits to using different types of blasting media? So what we're looking at through some of our more forensic capabilities, like scanning electron microscopy, FTIR and XRF capabilities, is we're getting down into the elemental level and trying to analyze, is the media that we're using leaving behind any molecular properties, different chemical properties that are beneficial to the coating application process and to the service life. So, for example, we use a lot of zinc in our coatings for primers and hydraulic steel structures. Zinc gives a very nice barrier to corrosion, and so zinc is very toxic to the environment. It's very heavy. It's very hard to work with, and so what we're trying to look into now is, can these new alternative medias provide some of the same benefits without having to use the heavy metal primers?
Well, and you've already touched on this a little bit, but I'll go into this question of, why is it important to test and evaluate different types of paints and coatings in the laboratory and in the field?
So one of the biggest reasons I always circle back to, and I kind of feel for quite a bit, is all of our work is in direct support of either our civilian infrastructure and populace, our military, or both. So that's a big deal, Right. So one way to think about it is, coatings have a large role in our daily lives that a lot of people don't quite ever truly realize or appreciate. So, for example, it's like, your car is painted, right?
Right.
Or your building materials in your house are treated with fire retardant coatings, which help keep you safe longer in emergencies. But those are things you don't really think about, or think, with our nation's water systems, all of our different pipelines and drainage systems that are coated and have to be protected so they don't degrade, so that we can handle storm surges or just even human waste, in a responsible way.
Right.
So those all play into why we do what we do. But on the other side, those are all good public safety and health. But at the end of the day, too, everything has to come back to the dollar.
Right.
So it's also where, people think, oh, you get out and you just throw some paint on it. It's going to look great. Pick the color you want. You're done. Right. Cover that rust right up. But what they don't realize is that a coating that's properly applied can save millions of dollars on a single job site, just in direct cost alone. So I keep talking about like hydraulic steel structures like locks and dams, for example. But when you're working on these, they're corroding, they've got rust problems. You're talking millions of dollars in dewatering, remediating the old coating, repairing the gates, getting these back into operation. And if the coating is any step in that application process performed poorly, you've got to circle back and do it all over again.
Right.
So you're re-spending those millions of dollars, but then also there's all the second and third order effects. So when you're shutting down these public waterways, or you're shutting down a structure for maintenance. There's all these other second and third order effects where there's other costs. So like on the waterways, for example, it's commerce. All the freight that's moved up and down the waterways on barges and things, that all has to come to a halt or has to be rerouted or slowed down. So it's vital to get these jobs done properly the first time.
Right. You can give the analogy of, when you're painting at your house, you want to do it right the first time so you don't have to steadily go back year after year and do something that you should have done right the first time.
Exactly. Anything worth doing is worth doing it right.
Exactly.
So,
exactly.
do it right the first time and save yourself a lot of headache, a lot of frustration.
Exactly. So we're going into, so I know you've got to face some challenges or difficulties. What are some of those when working with paintings and coatings?
Yeah, so it's really kind of case by case, but in general, Mother Nature is something we are always going to square off with. Every coating requires a different application parameter for things like its ambient temperature, the actual temperature of the workpiece. So maybe it's the steel or the wood or the masonry unit that you're working on. Even things like the relative humidity in the air, the salt content, like I mentioned earlier, from the weathering concerns, and just honestly like precipitation, like inclement weather, storms and things like that wreak havoc in the field. And then another problem we often face is it's not really anybody's fault, but it's the lack of knowledge of how important things like surface preparation and remediation of the previous coatings are. Mm-hmm. Trying to do that right, like we just talked about, doing that right the first time, or doing it in a safe manner. So one example is we have a pier out at Duck, North Carolina at our field research facility. That's in the ERDC here. And they've got the longest pier on the eastern seaboard that goes way out into the ocean. But one thing when you're talking about maintaining that asset is you have the general public that's around, but also the ocean and marine life there. So how are you going to perform this in a safe manner with the open ocean, but also in a safe manner for the environment and the civilian populace that's around you?
Right.
Those are some really tricky challenges.
This year, we're celebrating how the labs came together 25 years ago to form one ERDC, one organization of experts across multiple disciplines. How do you collaborate with other researchers, organizations, or stakeholders in the field of paint technology?
So I've kind of touched on this a little bit, but
Yes.
We'll dive in a little more detail here. So like I said, given our mission set being so wide, where we work on basically all things infrastructure across the DoD civilian and military sectors, it really lets us work with anybody across the Corps of Engineers, the greater DoD, academia, and private industry. So, for example, like our field support side, we're in constant contact with USACE districts on specific jobs and third-party contractors during the actual working process. On our quality assurance side, we work directly again with different districts and private industry that are sending in their coatings to get validated by our team. And then on the R&D side of the house, we get really diverse as well. So we work heavily with academia. So different universities, like I said earlier, the University of Illinois, North Dakota State University, University of Southern Mississippi, University of Akron, are all different academia partners that we work with, where we're in collaborative R&D efforts on a daily basis. We also work a lot with our sister labs. We've got ITL, CERL, CHL, EL, GRL, and GSL as other sister labs here in the USACE, and we actually work with all of them. So it's pretty exciting stuff. And then in private industry, we work with different paint manufacturers and different energy companies. And then as the broader DoD, we work with organizations like the U.S. Bureau of Reclamation, the Army Research Lab, Joint Munitions Command, Navy facilities and Navy Air Research branches, and then different Army commands like geographical commands and cross-functional teams. So all of these relationships, different remote collaborators, we work at different levels with each of these guys. So like I said earlier, some of them are the 6-1, the real exploratory research stages, all the way through to final field demonstrations and validation of technologies as we try to get the R&D out to the real world.
Right.
whether it's the civilian sector or to the military force.
Right. And we've already, I think we grabbed a hold of the next question that we were going to talk about is the benefits or the impacts of working with these groups.
Yeah, exactly. So I'll just touch on this a little bit. I know there were a couple ones where, we touched on how coatings, can save time, they can save money, they're valuable to public health. But also, we will also work on things like latent energy usage. So that's good for our power grid, basically making our buildings work for us.
Right.
So how do we absorb more sun versus reflect more sun, given the time of year or the geographic location? So just another one just to touch on that.
Okay. So how do you keep up with the latest developments, trends, or innovations in paint technology?
So I will have to definitely give credit to our predecessor, Al Beidelman, an amazing researcher who's retired now, but we call him the father of the paint lab.
And he knows that, right?
Oh, yes.
Okay.
We hold him in very high regard, and he's been around with the team since the 1960s, actually. And so we miss him today, but he really left a heck of a legacy. And so we are still benefiting today from the reputation that he's built across the USACE and really across the globe. Like you said earlier, hey, you didn't realize we had a paint team, but there are a lot of folks out there that do realize we have the Paint Technology Center. Mm-hmm. And so people he was able to reach, it really strengthened our team and our position as we move forward. But that aside, thankfully to Al, we had him. But moving forward, I'm a little biased. I think our team's pretty amazing. We have a really strong team here where we've got a pretty diverse background. We've got several different vets with various backgrounds like myself. We've got different types of engineering disciplines that are in the Paint Technology Center, like mechanical engineering, electrical engineering. We've got Dr. Wilson, who's a chemist. So we've got a really diverse team there. But to really keep up on things, the team is really good at making sure there's a presence at different professional conferences and symposiums to where we can network. We get out there and present our research findings. We do a pretty decent job at getting published in journals and articles. And so vice versa, we try to keep up on those presentations and articles ourselves. Several members of the team also work on different national and international working groups and committees to where they actually get out there and protect our interests both at a national level here in the States and also abroad. And then also bring back different best practices from around the globe and see how our fellow allied nations are maintaining their military and their civilian infrastructure in their countries as well. And then we also try to stay relevant just because of our wide net. So I've talked several times about, our different partners and how wide of a range we get to work with, as far as our different collaborators and partners and things like that across the USACE, the DoD, academia, and industry. And I think that's probably one of our best assets as far as staying up to date on technology and where the industry goes, is because we're forced to plug in so many different avenues. Okay.
So as we wrap up here, what would you like listeners to remember from this valuable conversation?
So I would say, I would just want people to remember there's a lot more to coatings and paint than just picking a color.
Right.
Paints and coatings, they can make your asset look great, whether it be the building or, a vehicle. But at the end of the day, selecting the proper coating, applying it properly, and then taking care of it during its service life is going to save substantial amounts of time and money. But at the end of the day, it can also save lives of both service members and civilians alike. The coatings protect the assets. And I think that's an important part to remember.
Thank you so much. Is there anything else that you'd like to add to our conversation today?
I really think that's it. I really appreciate you taking the time and giving me the opportunity to talk a little bit about our team.
That's great. Thank you so much. And thank you, Drew Miller.
The U.S. Army Engineer Research and Development Center, or ERDC, is the premier research and development center for the U.S. Army Corps of Engineers. Hello, I'm Carol Coleman, and I would like to share with you how ERDC makes the difference. Established in 1998, the ERDC is home to more than $1 billion worth of world-class facilities located in 7 laboratories and multiple field sites across the country. The organization's main campus is situated on the historic Waterways Experiment Station in Vicksburg, Mississippi, and consists of the Coastal and Hydraulics Laboratory, the Environmental Laboratory, the Geotechnical and Structures Laboratory, and the Information Technology Laboratory. ERDC also operates 3 laboratories not located on the West Campus, including the Construction Engineering Research Laboratory in Champaign, Illinois, the Cold Regions Research and Engineering Laboratory in Hanover, New Hampshire, and the Geospatial Research Laboratory in Alexandria, Virginia. Each laboratory has their own unique mission and operates as integrated teams of engineers and scientists to address a broad range of science and technology issues. The Coastal and Hydraulics Laboratory, or CHL, addresses an entire spectrum of water resource challenges. Their mission is to deliver solutions to our nation's most challenging coastal and hydraulics problems. As part of the CHL, the Field Research Facility, or FRF, is a U.S. Army Corps of Engineers field site located in Duck, North Carolina. The cornerstone of the FRF's contribution to coastal research has been its long-term data measurements that stretch back to 1977. The long-term measurements have made the property one of the best studied beaches in the world. Providing solutions for tomorrow's environmental challenges, the Environmental Laboratory, or EL, is ERDC's primary center for ecosystem science, ecosystem technology, and environmental resiliency research. The laboratory is home to the Aquatic and Wetlands Ecosystem Research and Development Center and the Hazardous Waste Research Center. ERDC's Geotechnical and Structures Laboratory, or GSL, supports our nation's defense, security, public safety, and infrastructure. GSL is home to the world's largest heavy vehicle simulator, the Centrifuge Research Facility, and the Advanced Blast Load Simulator. In today's fast-paced digital environment, the Information Technology Laboratory, or ITL, provides innovative solutions to solve the nation's most complex and challenging IT and computational issues. The laboratory's Supercomputing Resource Center is one of only 5 Department of Defense computing centers operated by the DoD High Performance Computing Modernization Program. For more than 50 years, ERDC's Construction Engineering Research Laboratory, or CERL, has supported the Army's ability to design, build, operate, and maintain its installations and contingency bases. Located in Champaign, Illinois, the laboratory is home to the Triaxial Earthquake and Shock Simulator. ERDC's Cold Regions Research and Engineering Laboratory, or CREL, delivers environmentally relevant and transformative engineering solutions to test, evaluate, and improve infrastructure and equipment, particularly for use in cold regions. Located in Hanover, New Hampshire, the laboratory is home to the Frost Effects Research Facility, the largest refrigerated warehouse in the United States. The Permafrost Tunnel Research Facility is a U.S. Army Corps of Engineers field site operated and maintained by ERDC's CREL. The tunnel, located just outside Fairbanks, Alaska, is a unique natural research facility with features up to 40,000 years old. ERDC's Geospatial Research Laboratory, or GRL, located in Alexandria, Virginia, serves as the Geospatial Research and Development Laboratory of the U.S. Army Corps of Engineers. GRL is the only dedicated geospatial research and development laboratory in the entire Department of Defense. As the premier research and development center for the U.S. Army Corps of Engineers, ERDC has unique, world-class equipment and facilities. To learn more how ERDC discovers, develops, and delivers innovative solutions to the nation's toughest challenges, be sure to listen to Beyond the Gates on News Talk FM 107.7 on Thursdays at 8:15 a.m. and 9:10 a.m. or check out past shows on vicksburgradio.com. We discuss exciting research with representatives from one of the 7 ERDC laboratories, and they describe how their projects are important to the community, the region, and the nation. Again, I'm Carol Coleman with ERDC. Thanks for listening.